So today's our topic is vitamins. The vitamins speak we are for growth, health and welfare of organism. Discharge our duty directly or through coenzyme deficiency symptoms. We shall be with the additional supplements. Vitamins are two types, fat soluble and water soluble. It is difficult to define vitamin precisely. Vitamin may be regarded as organic compound required in the diet in small amounts to perform a specific biological function for normal maintenance of optimum growth and health of the organism. The bacterium E. coli does not require any vitamin as it can synthesize all of them. It is believed that during the course of evolution, the ability to synthesize vitamins was lost. Hence, the higher organisms have to obtain them from diet. The vitamins are required in small amount since their degradation is relatively slow. History and nomenclature of vitamin. In the beginning of 20th century, it was clearly understood that the diets containing purified carbohydrates, proteins and fat, and minerals were not adequate to maintain the growth and health of experimental rats, which the natural food could do. Hopkins coined the term accessory factor to the unknown and essential nutrient present in the natural food. Funk isolated an active principle, amine from rice polishing and later in yeast, which could cure beriberi in pigeons. He coined the term vitamine, Greek vita life, to the accessory factors with the belief that all of them were amines. It was later realized that only few of them are amines. The term vitamin, however, is continued without the final letter E. The uses of A, B, and C to vitamin was introduced in 1915 by McCollum and Davis. The first felt they were only two vitamins, fat soluble and water soluble. Soon another water soluble anti-scurvy factor named vitamin C was described. Vitamin A was later found to possess two components, one that prevents night blindness and another anti-regate factors named as vitamin D, a fat soluble factor called vitamin E, in the absence of which rat failed to reproduce properly, was discovered. Yet another fat soluble vitamin concerned with coagulation was discovered in the mid 1930s. It was named as vitamin K. Sequences of alphabet should have been F, but K was preferred to reflect its function coagulations. As regard the water-soluble factor, vitamin C was identified as a pure substance and named as ascorbic acid. Vitamin B was found to be a complex mixture and nomenclature also became complex. B1 was clearly identified as anti-beriberi factor. Many investigators carried out intensive research between 1920 to 1930 and went on naming them as the water-soluble vitamin B2, B3, B4, B5, B6, B7, B8, B9, B10, and B11, and B12. Some of them were found to be mixture of already known vitamins, and for this reason, a few members of the B complex series disappeared from the scene, except B1, B2, B6, and B12. Names are more commonly used for other B complex vitamins. Classification of vitamin. Here are about 15 vitamins essential for humans. They are classified as fat soluble A, D, E, and K, and water soluble C and B groups. Vitamin as known as in the table 7.1. The B complex vitamin may be subdivided into energy releasing B1, B2, B6, biotin, etc. So this is the chart of classification of vitamin: fat soluble, water soluble. Vitamin A, D, E, K fat soluble. Vitamin B complex, non-B complex, vitamin C and B complex, energy releasing and hematopoietic. Energy releasing thiamine, riboflavin, niacin, pyridoxine, biotin and pantothenic acid. Hematopoietic is folic acid and vitamin B12. Hematopoietic, folic acid and vitamin B12. Most of the water-soluble vitamins exert the functions through their respective coenzyme, while only one fat-soluble vitamin K has been identified to function as a coenzyme. Vitamins, as per the definition, are not synthesized in the body. Synthesis of vitamins by intestinal bacteria. Vitamins, as per the definition, are not synthesized in the body. However, the bacteria of gut can produce some of the vitamins required by man and animal. The bacteria mainly live and synthesize vitamin in the colon region, when where the absorption is relatively poor. Some of the animal rat deer eats their own feces, a phenomena known as coprophagy. As far as humans are concerned, it is believed that the normal intestine bacterial synthesis and absorption of vitamin K and biotin may be sufficient to meet the body requirements. For other B complex vitamins, the synthesis and absorption are relatively less. Administration of antibiotics often kills the vitamin synthesizing bacteria present in gut. Hence, additional consumption of vitamin is recommended. Fat soluble vitamin. The four vitamins, namely vitamin A, D, E, K, are known as fat or lipid soluble. Their availability in the diet, absorption, and transport are associated with fat. They are soluble in fat and oils and also the fat solvent. Fat soluble vitamin can be stored in liver and adipose tissue. They are not readily excreted in urine. Excess consumption of these vitamins leads to their accumulation and toxic effects. All the fat soluble vitamins are isoprenoid compound since they are made up of one or more or five carbon units, namely isoprene units. Fat soluble vitamins perform diverse function. Vitamin K has a specific coenzyme function. Water soluble vitamin. General, the water soluble vitamin are a heterogeneous group of compounds since they differ chemically from each other. The only common character shared by them is their solubility in water. Most of these vitamins are readily excreted in urine and they are not toxic to the body. Water soluble vitamins are not stored in the body in large quantity except vitamin B12. For this reason, they must be continuously supplied in the diet. Generally, vitamin deficiency are the multiple rather than individual with overlapping symptoms. It is often difficult to pinpoint the exact biochemical basis of the symptom. The water soluble vitamin form coenzymes that participate in a variety of biochemical reactions related to either energy generation or hematopoiesis. It may be due to this reason that the deficiency of vitamin result in a number of overlapping symptoms. The common symptoms of the deficiency of one or more vitamin involved in energy metabolism include dermatitis, glossitis, cheilitis, diarrhea, mental confusion, depression, and malaise. Deficiency of vitamin B1, B6, and B12 is more closely associated with neurological manifestations. Vitamins. The term vitamins represent the chemically similar substances that possess qualitatively similar vitamin activity. Some good examples of vitamins are given below. Retinol, retinal, and retinoic acid are the vitamins of vitamin A. Pyridoxine, pyridoxal, and pyridoxamine are the vitamins of the vitamin B6. Individual vitamin. In the following pages, the individual member of the fat soluble and water soluble vitamin are discussed with regard to the chemistry, biochemical function, recommended dietary daily allowances RDA, dietary resources, deficiency manifestation, etc. Vitamin A. The fat soluble vitamin A as such present only in food of animal origin. However, its provitamins carotenes are found in plants. It is recorded in the history that Hippocrates about 500 BC cured night blindness. He prescribed to patients patents ox liver in honey, which is now known as contain high quantity of vitamin A. Chemistry. In recent years, the term vitamin A is collectively used to represent many structurally related and biologically active molecules. The term retinoids is often used to include the natural and synthetic forms of vitamin A. Retinol, retinal, and retinoic acid are regarded as vitamins of vitamin A. Retinol, vitamin A alcohol. It is primarily alcohol containing beta-alanine ring. The side chain has two isoprenoid units for double bonds and one hydroxyl group. Retinol is present in animal tissue as retinol ester with long chain fatty acids. Retinol. This is the structure of retinol and retinal and retinoic acid. Beta-carotene, the structure of vitamin A and related compounds. The related compounds are represented by red color. Retinol, a vitamin A, aldehyde. This is an aldehyde form obtained by the oxidation of retinol. Retinol and retinol are interconvertible. Previously, the name retinine was used for retinol, retinoic acid, vitamin A acid. This is produced by the oxidation of retinol. However, retinoic acid cannot give rise to the formation of retinol or retinol. Beta-carotene provitamin A. This is found in plant foods. It is cleaved in the intestine to produce 2 moles of retinol. In human, this conversion is insufficient, hence beta-carotene possesses about 1/6 vitamin A activity compared to the retinol. Absorption, transport, and mobilization. Dietary retinol esters are hydrolyzed by pancreatic or intestinal process border hydrolysis in the intestinal releasing retinol and free fatty acids. Carotenes and hydrolyzed by beta-carotene 1515 dioxygenase of the intestinal cell to release 2 moles of retinol, which is reduced to retinol in the intestinal mucosal cell. Retinol is re-esterified to long-chain fatty acid incorporated into the chylomicrons and transferred to the lymph. The retinol ester of chylomicrons are taken up by the liver and stored. As and when needed, vitamin A is released from the liver as free retinol. It is believed that zinc plays an important role in retinol mobilization. Retinol is transported in the circulation of plasma retinol binding protein in association with the prealbumin. The retinol complex binds to a specific receptor on the cell membrane of the cell membrane of peripheral tissue and enters the cells. Many cells of target tissue contain a cellular retinol binding protein that carries retinol to the nucleus and binds to the chromatin. It is here that retinol exerts its function in a manner analogous to that of a steroid hormone. Biochemical functions. Vitamin A is necessary for a variety of functions such as vision, proper growth, and differentiation, reproduction, and maintenance of epithelial cell. In a recent years, each form of vitamin A has been assigned a specific function. Vitamin A and vision. The biochemical function of vitamin A in the process of vision was first elucidated by George Wald Nobel Prize. The event occur in cyclic process known as Rhodopsin cycle and or Wald visual cycle. So this is the cycle. By this, we can easily understand the work of vitamin A in the production of rhodopsin. Beta-carotene antioxidant converted in retinol, steroid hormone growth and differentiation, retinol visual cycle, retinol phosphate, glycoprotein synthesis, and retinoic acid steroid hormone growth and differentiation. Rod and cones. The retina of the eye possesses two types of cell, rod and cone. The human eye has about 10 million rod and 5 million cones. The rod are the periphery, while cones are at the center of retina. Rods are involved in dim light vision, whereas cones are responsible for bright light and colored vision. Animals such as owls and cats, for which night vision is more important, possess mostly rod. Walled visual cycle. Rhodopsin, molecular weight 35,000, is a conjugated protein present in rods. It contains 11 cis retinal and the protein opsin. The aldehyde group of retinol is linked to sigma amino group of lysine of opsin. The primary event in visual cycle on exposure to light is the isomerization of 11 cis retinal to all trans retinal. This leads to a conformational change in opsin, which is responsible for the generation of nerve impulse. The all trans retinal is immediately isomerized by the retinal isomerase. This combines with opsin to regenerate rhodopsin and complete the visual cycle. However, the conversion of all the transretinal into 11 cis retinal is incomplete. Therefore, most of the all transretinal is transported to the liver and converted to all transretinal by alcohol dehydrogenase. The all transretinal undergoes isomerization to all 11 cis retinol, which is then oxidized to 11 cis retinal to participate the visual cycle. The dark adaptation time. What is the dark adaptation time? When a person shifts from a bright light to a dim light into a dim in a theater, rhodopsin stores are depleted and vision is impaired. However, within a few minutes, known as a dark adaptation time, rhodopsin is synthesized and vision is improved. Dark adaptation time is increased in vitamin A deficiency individuals. Bleaching of rhodopsin. When exposed to the light, the color of rhodopsin changes from red to yellow by a process known as bleaching. Bleaching occurs in a few milliseconds and many unstable intermediates are formed during this process. Rhodopsin, this is the cycle rhodopsin. Visual cascade and CGMP. When light strikes the retina, a number of biochemical changes leading to membrane hyperpolarization occur, resulting in the genesis of nerve impulse. This is the walled visual cycle.
तो मीठा है मीठा कम है
हाँ कम है लेकिन ठीक
डाल दो
नहीं अब का डाल रहा है अरे तो रिकॉर्ड हो गया rhodopsin and photon beta-rhodopsin GDP What is the color vision? Recommended dietary allowance RDA. The daily requirement of vitamin A is expressed as retinol equivalent rather than international unit IU. A retinol equivalent is 1 microgram retinol is equal to 6 microgram beta-carotene, 12 microgram other carotenoid, 3.33 international unit of vitamin A activity from retinol, 10 international unit of vitamin A activity from beta-carotene. The RDA of vitamin A for adults is around 1000 retinol equivalent to 3500 units international units for men and 800 retinol equivalents 2500 units for women. One international unit equal to 0.3 mg retinol. Dietary sources. Animal sources contain performed vitamin. The best source are liver, kidney, egg yolk, milk, cheese, butter, fish, cod, and shark liver oil are very rich in vitamin A. Vegetable source contain the provitamin Vitamin A deficiency. Vitamin A deficiency. The vitamin A deficiency may be due to inadequate dietary intake, impaired intestinal absorption, reduced storage in liver, and chronic alcoholism. The deficiency syndrome are not immediate since the hepatic deficiency manifestation of the eyes. Night blindness, nectalopia, is one of the earliest symptoms of vitamin A deficiency. The individual have difficulty to see in dim light since the dark adaptation time is increased. Prolonged deficiency and reversible damage number of the visual cells. Severe deficiency of vitamin A leads to xerophthalmia. This is characterized by dryness in conjunctiva and cornea and keratinization of epithelial cell. In certain areas of conjunctiva with triangular plaques known as biotite spot are seen. The xerophthalmia persists for a long time. Corneal ulceration and degeneration occur. This results in the destruction of cornea and condition referred to keratomalacia, causing total blindness. Therefore, adequate intake of vitamin A is necessary for the prevention of the blindness. Other deficiency manifestation, effect on growth. Vitamin A deficiency result in growth retardation due to impairment in skeletal formation. Effect on reproduction. The reproductive system is adversely affected in vitamin A deficiency. Degeneration of germinal epithelium leads to sterility in males. Effect on skin and epithelial cell. The skin became rough and dry. Keratinization of the epithelial cell of gastrointestinal tract, urinary tract, and respiratory tract is noticed. This leads to increased bacterial infection. Vitamin A deficiency is associated with formation of urinary stones. The plasma level of retinol binding protein is decreased in vitamin A deficiency. Hypervitaminosis. Excess consumption of vitamin A leads to toxicity. The symptom of hypervitaminosis A include dermatitis, raised intercarnial tension, enlargement of liver, skeletal decalcification, tenderness of long bones, loss of weight, irritability, loss of hair, joint pains. Elderly people are more susceptible to vitamin A toxicity, hence overdose should be avoided. Total serum vitamin A level normal 20 to 50. Beneficial effects of beta-carotene. Increased consumption of beta-carotene is associated with decreased incidence of heart attack, skin and lung cancer. Beta-carotenes, which is independent of its role as a precursor of vitamin A, ingestion of high dose of vitamin beta-carotene for a long period are not toxic like vitamin A. The next one is vitamin D. Vitamin D is a fat-soluble vitamin. It is resembles sterols in structure and function like hormone. Ergosterol, sunlight, ergocalciferol. Absorption, transportation, and storage. Vitamin D is absorbed in a small intestine, of which bile is essential. So, lymph vitamin D enters in the circulation bound to plasma, alpha 2 globulin, and is distributed throughout the body, liver, and other tissues. Store small amounts of vitamin D. Metabolism and biochemical function. Vitamin D2 and D3 as such are not biologically active. They are metabolized identically in the body and converted to active forms. The metabolism and biochemical function of vitamin D are deficient. Synthesis of 125 DHCC. Regulation of the synthesis of 125 DHCC.